Welcome back to my channel and thanks for being here. In this video, I would like to discuss about aircraft propulsion system. So let's get started. The integration of propulsion system for an aircraft started from the early 20th century. On December 17, 1903, Orville and Wilbur Wright, also known as Wright brothers, flew their aircraft, the Wright Flyer. It was equipped with an inline 4-cylinder reciprocating engine which is capable of producing 12 horsepower. On an average, the cars we use today are capable of producing 180 to 200 horsepower. The use of reciprocating engines in aircraft is still carried out because of their improved efficiency and the advantages they provide over the other engines. Let us now look at the working principles of all these engines. The first one includes the reciprocating engine. The main parts include the cylinder, piston, crankshaft, camshaft, connecting rod, inlet and outlet valves, crankcase, and a spark plug. There are again two types of reciprocating engines, the spark ignition engine or simply SI engine and the compression ignition engine or CI engine. The spark ignition engine contains 4 cycles which undergo continuously to generate the power. The first cycle is intake. In this cycle, the inlet valves are open and the outside air is drawn into the cylinder. During this process, the piston moves from top dead center to the bottom dead center, creating vacuum-like space to allow the air inside the cylinder. Meanwhile, fuel is sprayed into the cylinder which gets mixed with the air. The second cycle is compression. In this cycle, the inlet valve is closed and the piston moves from bottom dead center to the top dead center. During this phase, the volume of cylinder is decreased, which leads to increase in pressure. The third cycle is power. With the help of spark plug, the fuel-air mixture is ignited in this cycle. Combustion happens in the cylinder and the chemical energy is converted into mechanical energy. Due to the expansion of gas, the energy gets transmitted to the piston, which moves from top dead center to bottom dead center. The piston is connected to the crankshaft with the help of a connecting rod. So the power is transmitted to crankshaft through the connecting rod. The crankshaft is connected to the propeller in an aircraft. The power produced by the engine is huge, so reduction gears were used before it reaches the propeller. The fourth cycle is exhaust. In this cycle, the piston moves from bottom dead center to the top dead center. In this phase, the exhaust valves open and the burnt gas is sent out. The spark ignition engine is designed in such a way that all 4 cycles complete within 2 rotations of the crankshaft. Since the power produced in the third cycle is huge, it can be utilized for further rotation of the crankshaft, which means power is produced for every third cycle and for next 3 cycles this power can be utilized. So once the cranking is done for the engine, the cycles repeat and the engine works continuously. The other type of reciprocating engine is compression ignition engine. The name itself suggests that ignition of air-fuel mixture happens within compression. It contains only 2 cycles. In the first cycle, both intake and compression is carried out simultaneously. When the piston moves from bottom dead center to top dead center, the air is allowed into the lower section of the cylinder. At the same time, the compression of air-fuel mixture happens at the upper section of the cylinder. During this phase, the fuel is injected into the cylinder and the air-fuel mixture gets compressed. The second cycle includes both power and exhaust. Due to compression, temperature is increased in the cylinder and the air-fuel mixture gets ignited. Then, the conversion of chemical energy into mechanical energy takes place, which moves the piston from top dead center to bottom dead center. Similar to the spark ignition engine, the piston transfers this energy to the crankshaft through the connecting rod. At the end of the cycle, the exhaust valve is opened and the burnt gas is sent out. In the meantime, the fresh air is allowed to pass into the cylinder. From the early days, aircrafts with reciprocating engines are mostly equipped with spark ignition engine because it is easy to construct them. Since the spark ignition engines consume more fuel, manufacturers are trying to replace them with a more feasible compression ignition engine. This might be seen in near future since it is quite complex to manufacture them. The working of gas turbine engines will be explained in the next video. Thanks for watching.